Rethinking industrial engineering involves developing new science, new tools, and training our students to be able to solve the grand challenge problems facing society tomorrow. Here at Purdue, the grand challenges we are looking to address with the Rethink IE efforts are providing affordable healthcare to people around the world, clean drinking water and food, energy supply, and also to develop products that are personalized to each human being's needs.
What robust optimization can do is we can forecast that sparing organs at risk by robustly optimizing the treatment plan to the changing tumor, we can spare organs at risk and other healthy tissue. An illustrative example in robust optimization is in lung cancer. The typical techniques would deliver the same radiation plan over the course of 6 weeks without any changes. The problem is, if the tumor changes in size, let's say, then we will be delivering a lot of high-dose radiation to healthy tissue. Robust optimization allows us to spare the healthy tissue significantly better while we still achieve the same clinical goals for the target.
One of the biggest challenges facing our country today is being able to deliver affordable health care. Here at Purdue, one of the ways that we're looking at improving the affordability of health care is looking at incentives. How can we create incentives that will help, for example, individuals make better choices, whether it be about their diet or their exercise or showing up to an appointment? What types of incentives can we design that would help improve that? Another way would be at the organizational level, looking at how can we develop policies that make sense for the way insurance pays their physicians, so that the physicians are making cost-effective decisions.
I believe future IEs will play a key role in healthcare, particularly because IE brings in various disciplines together and combines the knowledge of these disciplines together to deliver the best solutions. And moreover, IE attempts to have a systems approach to things instead of dividing the problem into small niches and creating sub-problems of the interfaces.
The energy work at Purdue is of many fronts, and there's technology aspects, for example, like the battery technology, like solar panel technology. Then there's also a market analysis aspect that's more related to my work. There's also on the cybersecurity aspect, and also the computational algorithms behind this entire smart grid operations. Many people may still remember that the 2003 blackout that basically wipes out the electricity out of the entire northeast regions of the United States and Canada. And that's just because the delicacy of this electricity system, that the supply-demand has to be balanced all the time. As long as there's imbalance, then this imbalance could so-called cascade, and then it could bring down the entire system down within just a matter of minutes. The smart grid is really to address those failures to make sure the system is much more reliable than today. The smart grid will make this grid very smart in the sense that it can prevent beforehand such so-called cascading effects to be happening.
Purdue IE's work on the next generation air transportation system is trying to get the system to handle 2 to 3 times the amount of traffic that it handles today without excessive delay. We're looking to introduce new technology into the system, satellite technology and airborne broadcast technology, things like this, in order to make the system more efficient. The one thing we hope they'll see is that there'll be less delay, it'll be less brittle. They may also start to see things like uninhabited aerial vehicles being incorporated in the system, so they may see pilotless airplanes being incorporated, but hopefully it will just be a better experience for them.
The collaborative process that we have in Purdue and IE, I think, is really cool and unique because we are able to have teams of students put together all the pieces that they've learned in their 4 or 5 years of undergraduate, and they get to work with a real external customer on a real problem. So we don't script the problem. These are real customers that have real sources of pain. And the students are not just doing this as a final academic thing, but their first real professional experience.
At the Purdue School of Industrial Engineering, we are rethinking industrial engineering for the next 25 to 50 years.